But you guys are strong and you should be able to get it, even though it might be a bit abstract. Association rules mining. Association rules mining. I've put the slides also there for you to follow. When we talk about association, what comes into your mind? Right. When we talk about association, what comes into your mind? It is your participation that makes me explain things better. Otherwise, you might see that I'm just flowing. What comes into your mind when it comes to association? When we say certain things are associated.
And probably the synonym relation.
Benjamin.
When two things are related.
Yeah, you spoke about two things, but I'm talking about when several things.
Okay, so let me see when several things are related or linked in a certain way.
Give me something, three different things that might be related, and let me see.
So let me see in studies we can say study and test scores are associated.
What are associated?
Study scores and study hours and test scores.
How many are the items?
2.
The items you just mentioned, how many are they?
2.
I want items that are three or more. Anybody? Cooker.
Okay, Doc, please, I've tried. So, bread, butter, and coffee.
Good. What makes you think they are associated?
Okay, so when let's say I buy bread, I'm likely to buy butter and then eat it with coffee. So they are like hand in hand, sort of.
So now that cooker has opened the doorway, can somebody else give me something else which has nothing to do with food? Can you give me something else which has nothing to do with food? Yeah.
Thank you, Doc. I think a keyboard, a mouse, and a monitor.
Very good. Who can give me another example? That has nothing to do with computers. Guys, I'm helping you to think from the beginning. Yes, Mr. Tigigria, Ruta Santo.
I'll try. I don't know if it's correct. Your age, your gender, and then I don't know. And your date of birth.
Your age, your gender, and your date of birth. Very good. What else? Benjamin.
Not instruments, beats, lyrics, and concerts.
Come again.
Instruments, beats, lyrics, and artists.
What's the last one you mentioned?
Artists.
Okay. Hey, what do you need when I papa? Jaja Sante.
Poor engine oil.
Sorry, come again.
Car engine oil fuel.
Can you make it 4 items? 4.
Filters.
Very good. All right, so guys, you're understanding the picture and the concept you are painting. So you're able to see this woman making some purchases and you're able to draw some association. Okay, you're able to solve. So we're going to look at the basic concept of association rule mining. We're going to look at something known as apiary algorithm. Different data formats for mining. Mining with multiple minimum supports. Mining class association rules. and then a summary of everything. Okay. Now, what is association rule mining? What is association rule mining? It is a data mining approach. We use it to check, identify, discover interesting associations, interesting relationships, interesting patterns, interesting linkages, not between variables, but among variables, because they are always large information that we have. For example, the human part alone has got large information. There is a connection between the eye specialist and then the GP. There is a connection between the skin specialist and the GP, or the ear specialist, and things like that. Even in the human body, there are so many associations. And there has to be a rule before you can mine the association. And that is the essence of association rule mining. It was instituted and propounded by a guy known as Agrawal et al. In 1993. And one beautiful thing about association rule mining is that it doesn't deal with numerical data type. It's for categories, groups, and therefore it's for categorical data. It's not good for algorithms for numeric data. At first, association rule mining was used for market basket analysis. That was the original intent. Market basket analysis. And the idea was to find how items bought by customers are related. And one of you just gave a beautiful example that if a person buys bread, there's a likelihood that a person is going to buy butter, she says, or milk. She says coffee, but butter or milk or coffee. And that will require that you know the support, which is a SUP. Write it down. You just write it down. You don't understand it yet, but you just write it down. That will require that you know the support and you know the confidence. So in such a case, it may be that the confidence is 100%, but the support is 5%. Shall look at these items. But that is the association. So items that are bought using your credit card, these are practical application of associations. If you use your credit card to buy, like you rent a car, you use your credit card, you rent a hotel, you use a credit card, okay? Support insight, so those items on the credit card support an insight into the product that a customer is likely to buy. It gives you an idea of what a customer is likely to buy. Even the credit card company will detect what a customer is likely to buy, because once you get into that rental cars, then the next couple of things, once he's got a car, he's going to be buying fuel, he's going to be doing services and so forth. So there is some associations there. The credit card company can detect the association. Also, we have optional services bought by telecom users. For example, call waiting, call forwarding, DSL, speed dial, speed call, all of those things. If a person uses one, there's a connection, an association of which one else the person is going to use. You're able to support how to bundle these services together. So because you know that, these people are using, for example, there is something in Vodafone, Telecel known as Black. Are you guys aware of it? So you know that these Black people are those that are paying monthly. But there are certain things they like to do. They are more likely to do international calling. So you bundle that into their package because you know that's what they will like, and then you give it to them. Another example is banking services. It's used by retail users a lot. For example, money industry account, certificate of deposits, investment services, car loans. They know the same people are the ones doing the same things. There is a connection, a linkage, a pattern, an association. And these banks are able to recognize the users that they are going to use this one since they've used that one. For example, if a user is able to do contract save, that user is likely to ask for more investment derivative instruments. But there are some people who do current account. You know clearly that the next couple of years they are going to be stuck to that. But the moment the person comes and say that, okay, I want to be able to do treasury bills, then you can now recommend stocks, you can now recommend other mutual funds, you can now recommend, you get association. Are you guys with me? I need to be sure you are listening. Are you with me?
Yes, Doc.
Oh, it's okay. So association rule mining has got a multiple. Let's look at another example. Unusual group of insurance claims can be an expression of fraud, and then it can spark a higher investigation. For example, you don't normally take 10,000 CDs from your bank. All of a sudden, you go to the bank or you go to the ATM, you go and take 10,000 because you have a limit of 200,000. 2 hours later, you count for 20,000. 3 hours later, you count for 10,000 again. It sends a signal. Because there is some kind of association around these kind of incomes. It sparks an investigation. The insurance, or the banking company want to really, really understand. In fact, sometimes they'll call you and tell you that, no, you can't do this. If you look at the medical patient histories, okay, it can use that to also connect some association. You can use genetics to do some association. That since there is an association, possibilities, likely complications based on definite set of treatments. These are all applications of association rule mining. So let's try to dig into association rule. Let's try to give some definitions before we go into the details. There's a term you're going to hear a lot, which is known as item set. Item set. An item set coalesces or combines one or more items. So when you have one or more items, let's say you have egg, you have bread, you have milk, you have sugar. Okay. An item set will contain, it can be one item, it can also be multiple items, but we call it like a basket of things. That is an item set. The collection of items in a set. Okay. And we normally use the curly brackets to indicate that this thing is an item set. So as an example, you have bread, peanut butter is an item set. Bread alone is an item set. Bread, peanut butter, and toothpaste is also an item set. Now, suppose you have a company and the company sells N items. That is the total number of items within, the shop. Then the number of possible items set is going to be 2 raised to the power n. Why? The reason is because the reason for the 2 is that we are talking about the fact that the item is included or is not included. So it is the included this word is not excluded, but it's included or excluded. Just a second, let me just correct that. It's included or excluded. Okay. So the possibilities, the possible number of items that a person can actually talk about within this company will be defined by 2 raised to the power n. Why is it 2 raised to the power n? is 2 raised to the power n because the item is either going to be included, which is a 0, or excluded, which is 1. So there are 2 possibilities. Okay, raised to the power n. So if you have, for example, 10 items, please confirm if you see the screen.
Yes, please.
Yes, Doc.
Okay. If you have 10 items, okay, not necessarily in the set, but 10 items, okay, then we are now looking for the set. Then the number of possible item sets is not going to be 10. Who can tell me why it's not going to be 10? It's not going to be 10. Who can tell me why? Because if it is 10, then it means that we've reached it. But then we are talking about a set. And 1 can be a set, 2 can be a set. So how possible? How are you doing the possibilities? Who can tell me? Why is it not going to be 10? Because there are 10 items, but the possible number of item sets is not 10. Why? Yes, Benjamin.
But we are looking at the possible subsets or the possible combinations you can make with all the 10 items available in the shop. So you can have maybe if there's, let's say, 10 items that include bread and butter, you can have the first one and the second one, the first one, the third one, the first one, the fourth one, till and then you come and have 3, first, second, third, first, second, fourth, first, second, fifth, till it's exhaustive.
Exactly. And what is the possible large set?
So the possible large set is all the items,
Which is in this case?
all the 10 items.
Exactly. And so because 1 can even be a set, that is why the possible number of item set is going to be 1024 for this example. Okay. We need to model any data set. Yes. Benjamin, your hand is up.
Doc, so the previous slide,
Let me go back there.
so it says that an item set is a collection of 1 or more items. Yes, but my knowledge from this formula, 2 to the power n, always includes an empty set, that is 0.
Yes. No.
So
An empty set is not 1 or more items. Because remember the word item set.
yes, so
Yeah,
that brings my
mathematically you are right. Mathematically, but we don't normally have. I mean, it's possible. It's not that it's impractical. It's practical. A person can go to the shop and buy nothing, isn't it? But if
Yes.
you buy nothing, will you hold a basket?
No.
Yeah. So that is why.
So that brings my question to the fact that with this formula, 2 to the power n, I always know that there's always an empty set included.
Yeah,
But it says an item set is 1 or more. So if 1 or more, are we not supposed to take the empty set out? We should give us 2 to the power n minus 1.
So 2 to the power 9. That's what you mean.
So 2 to the power n minus 1.
Yeah, where then if it is minus 1, then in this example it becomes 9.
No, not the power minus 1, but a whole number 1. So what I mean is 2 to the power n, then a minus 1, like not to the power, but a whole number minus 1.
Whole number minus 1. No. No, you cannot do it like that, because when you do it like that, when you are calculating, that's why I give you the example that when you are calculating, the empty set will not be part of the item set in practical sense. And so you wouldn't tell the person to stop because he bought nothing. You are able to only calculate that the person should stop because he bought something. And that is why you cannot incorporate that. If you subtract, like I said, I know that it mathematically it will include that empty set, but practically it is not part of the item set. You just check.
Okay.
But when you include, let's say that you said a basket of items can even be an empty set. When you are actually measuring the items in the set, you don't also include that empty set technically. Or you do. I mean, those permutations that you gave.
Yeah, so the empty set is always included. So I don't know if we can use the bread and peanut butter as an example. So there are two items in this set. So if you want to look at the combinations, you have bread as one, peanut butter as also one. That's two. And then the third is bread and peanut butter. So the fourth combination will have to be the empty set.
2 raised to the power 2 is what?
4.
Let me see. Yeah, it's 4. So you said bread and peanut butter, right?
Yes.
So bread is 1. Peanut butter is 2. Bread and peanut butter is 3. Empty set is 1. Yeah, mathematically that is 2. Mathematically that is true. But I'm only saying that practically. I'm only speaking in practical terms. But mathematically that is true. Let me just ask you, suppose you are an owner of a shop. Suppose you're an owner of a shop, would you, how do I put it? Would you calculate whether people buy or not?
No.
Mathematically, it's right. There's no problem mathematically. But I'm only saying that in the practical sense. I mean, I can attach practicality to it. The only practicality is that you be concerned when people are not buying. Yes, so mathematically, that is true. You include the 0 or the empty set as one of them. I'm only saying that practically, it doesn't make sense. But if we have to make practical sense, then you just include the fact that if people are not buying, or if somebody comes and doesn't buy your items, you become concerned. You take into consideration of that. Mathematically, that's correct. Is that okay?
Okay.
It's your question that you've asked. It's probably only you who understands it. Okay, the rest must understand it to ask that particular question. Okay, let's go on to the model. So you have a set of items. Now remember that this set of items has nothing to do with the item set. So when you go to the shop, as you can see on the top right, that is a set of items. Everything. We start from I1 all the way to IM, where M is the total number of items, irrespective of whether it's the same type or different type, categories or not. Okay. So I here, capital I here, is a set of all items in the store. You can make a transaction. That transaction will be a set of items. And that transaction is a member of that, all of the items in the set. So that transaction is what you see in the basket. So the basket is a portion or is a member of or a subset of the items that you have in the store. And this transaction is referred to as T. But then the transaction will have a database. So a set of transactions, okay, of course, let's say a set of transactions are these 4. Okay, there will also be a member of or a subset of the I. Would you agree with that? All these 4 will also be part of the I. And this one I, this basket, will also be part of all of the I. In other words, T is a subset of I, T is a subset of T. Do you guys get it? And therefore, T is a subset of I. I think you guys get it.
No, Doc, can you kindly come again?
Who understands what I just did? Because I've used the pictures here to clarify. Who understands what I just did? Benjamin, do you understand?
No, I'm trying.
Amayao,
Yes, Doc.
tell us.
So basically, you're trying to say that the set of items, so the individual items in the store, is a subset of the transactions that an individual can purchase. Then the set of transactions an individual can purchase is the set of transaction database. That is all the transactions that has been done in the store.
Okay. So the lady who says I should explain, do you get it? Or you still need further explanation? If you don't get it, just say I don't get it. It's not a wahala. Do you get it?
Yes, Doc, it's fine. I was just trying to get a transaction database. It's fine now. Thank you.
So the transaction database actually is also part of all the items in the store. So it's a subset of that. Okay. So now let's look at the transaction database carefully. The supermarket data itself. You have a market-based transactions. T1 is bread, cheese, and milk. T2 is apple, eggs, salt, yogurt. Now look at the items there, okay, and the number of items in each market-based transactions. And this will continue all the way up to Tn, which is biscuits, eggs, and milk. Now, who can tell me what does the N stands for? In this context, what does the N stand for? What does the N stand for? Yes, Pascal.
Said stands for the very last set.
Yeah, but what does it stand for practically? I mean, in simple way, what does it stand for? Angela.
Yeah, it stands for the last or the final transaction that was taken.
Okay, how is it connected to I? How is it connected to I? You know, I, all the items in there. How is it connected to that?
It's a subset of I.
Okay, to what extent is it a subset of I?
Because there are items that are in the store.
Oh, you are giving me short answers. I hope nobody will come and ask me a question on that because it looks like you're out. I mean, you should have asked that question. So let's look at an item. An item is an article or an item in a basket. I is a set of all items sold in the store. A transaction are those items bought in the basket. Okay. It may have a transaction ID. It may not have a transaction ID, but the items that have been bought in the basket. And then the database or the data set is that set of the transactions. Those are the concepts you got to get in mind because you're going to be using them. And so you have to look at them and have them clearly in mind. Maybe you may have to write them as we go further because you're going to be asking back, oh, what is that? What is that? What is that? This is it. So you might want to document that before we proceed. Okay. Next, we are going to give a certain kind of documentation, a text document data set. Each document is treated as a bag of keywords. So document 1 is a bag of keywords for students, for teach, and for school. Document 7 is a bag of keywords for basketball, team, city, and game. Document 3 is teach, school, city, and game. So you have this transaction data set. We've already said that a transaction contains X. X is a set of items. Okay, and this set of items are known as the item set in all of the item store. or all of the items in the store. Okay. So this X is also a member of the T. Remember, we indicated what T is, the transaction. Okay. Set. So an association rule implies that when X maps to Y, or it implies that X maps to Y, as long as X and Y are inside the item, all the items in the store. So as long as all of the items are in the store, okay, and they are part of the X and Y are part of all the items in the store, then you can say that X maps to Y. And that would mean that the intersection of X and Y is an empty set. Now, who can tell me why the intersection of X and Y will be an empty set? To avoid what? Why the intersection of X and Y will be an empty set? To avoid what? Who can tell me? To avoid what? Think of it like a Venn diagram, and then you can appreciate it. To avoid what? Or what does it mean to say that the intersection of X and Y is an empty set? What is the implication? Yes, Thomasia. Hey, I've never heard of this name, Thomasia.
Yes, Doc. So to avoid duplicates, since they are independent on their own.
Okay, when you say to avoid duplicate, what do you mean exactly? I get you, but what do you mean? Give me an example.
So they're not there. So basically, there's a set that has bread, milk, and sugar. Then there's another set that has TV remotes, mouse, just random things, and probably a keyboard. So they should not be related. Like they cannot belong. Keyboard cannot belong into a set that has bread and butter. I don't know if it makes sense.
Yeah, it makes sense to me. Okay. So guys, when you have something like X maps to Y, what does that mean? That statement of X mapping to Y, this very statement, what does this mean? What it means is that if a transaction contains all items in X, then it's likely to also contain all items in Y. That's what it means. It's a probabilistic implication. It's not logical, but it's a probabilistic. Let's take an example. Suppose I say that bread and butter, okay, let me just write it here. Suppose I say that bread, butter. Bread and butter maps to, let me just put it here, maps to milk. Bread and butter maps to milk. What do I mean here? What is it? What is the meaning of that statement I've just made? Bread and butter maps to milk. It means that if customers who buy bread and butter, okay, those customers who buy bread and butter often will also buy milk. That's what it means. Customers who buy bread and butter will also buy milk. But so what does the last part of X and Y is an empty set mean? If what I've just said is true, okay, if customers who buy bread and butter also buy milk, now what does the X intersection Y is an empty set? How is that connected to this bread and butter? The customers who buy bread and butter also buy milk. How does that connect? It means it makes no sense to create a rule that customers who buy milk also buy bread and butter. That's what it means. I want to repeat that. It doesn't make sense for you to say that customers who buy milk, I'm reading it backward from right to left now. Okay. It makes, It makes no sense to create another rule and say that customers who buy milk, also buy customers who buy milk also buy milk and bread. It would be trivial. And why would it be trivial? Because if a transaction contains milk, then of course it contains milk. So why would it tell me that it contains milk and it also, when I buy milk, I'll buy milk? So that sentence is enforcing the X and Y to be disjoint. That's what she said, that they don't have to be together. Because if when I'm buying this and I'm buying that already, so you don't need to tell me whether I'm buying this and that at the same time. Because they are already, intuitive. That is association rule. That is a rule that you have to think about. So the association rule is that bread, butter, customers who buy bread and butter also will buy milk. Okay. So the X here will be what? The bread and butter. And then the Y here will be what? Will be milk. And therefore the X intersection Y cannot be any of them. It's just an empty set because they're already contained in the previous. So I want you to know that an association rule that we just said is not symmetric. You can't say that, you can't say this. You can't say X maps to Y. This statement, X maps to Y, is not the same as Y maps to X. Just take note of it. It's not symmetric. X maps to Y is not the same as Y maps to X. It's not the same. It's also not logical truth. Okay, it doesn't mean that Y always follows X, like we just did. X maps to Y. Like customers who buy X will also buy Y. So it's like anytime you have to buy X before you buy Y. No, you can buy Y. Okay, but it's not symmetric. Okay, Y tends to occur with X. That's what it means. They occur together. So it's not like one must follow the other. They occur rather together. And the other thing is, you should know from this is that it's not a prediction guaranteed. It only indicates a statistical relationship, not a causation. It doesn't mean that buying X will lead to, no, it's not a causation. It's just a correlation. And it's not a causation. Okay, so let's take this next one here. An item is a set of items. An item set is a set of items. So when you have X, X is an item set, okay, which will contain things like bread, milk, and cereals. This is an item set. And therefore, a K item set or a K item set is an item set with K items. Okay, so this one that you see here, I was going to ask you, this one that you see here is how many item set, but it's already down here. So milk, bread, and cereal is a 3-item set. Okay, who can give me a 5-item set, including milk, bread, and cereal? A 5-item set, which includes milk, bread, and cereal. Who can give me a 5-item set? Of course, you must include them nicely. If it's not nicely included, it's not Pascal.
Milk, bread, butter, cereal, sugar.
So which 2 did you add?
I added butter and sugar.
Good. So let's continue. I mean, very good. So let's look at the rule. Okay, how do you evaluate? How do you measure the strength of the association? Remember, if we are doing correlation for numeric data and want to check whether there is a strength in association, you will use the Pearson's product moment correlation coefficient or the Spearman's rank correlation coefficient or the Kendall. Use all of these to measure the strength of the correlation. The correlation is between -1 and then +1. This is for numeric data. This is for numeric data. But, and of course, okay, let me ask you. If you have 0.9 in a numeric data, 0.9, negative 0.9, and then positive 0.8, which one is strong? Which one exhibits a strong correlation? You can tell us. Which of these two numbers exhibit a strong correlation? These two numbers you see. Oh, you've not done correlation before? Yes, Richard. Thomasia.
No, please, 0.8, 0.8.
Okay. Thomasia, you too.
Yes, positive 0.8.
Okay. Unfortunately, that is not correct. If you want to determine the strength of the correlation, it's going to be negative 0.9. Because the negativity is only telling you the direction. And so when you want to know the strength, you do not bring morality. Because the moment you say, you are making it look like positive is bad and negative is, sorry, positive is good and negative is bad. That's why you chose the 0.8. But the negativity doesn't make anything bad. For example, if you say that there's a negative relationship between price and quantity, if you increase your price and I reduce my quantity I'm buying from you, is that bad? Is it bad that I reduce my quantity, guys?
No.
No, please.
Yeah. So the relationship is negative. Does the negativity make the thing bad?
No.
Okay. So if you have two things, and one is 0.9, negative 0.9, and the other is negative 0.86 or 0.87, which one is showing a strong relationship?
The 0.9.
Exactly.
0.9.
So you ignore the negativity and take the absolute value because that will tell you the strength. Let me give you another example. Suppose you are in a relationship, and then there is, if I ask each one of you that your current relationships that you are in, if you are not in any relationship, don't worry, your relationship is zero correlation. But if I ask you that the current relationship you are in, is it positive or negative? It's likely that most will say positive, but some might say negative because it's boiling out there. Now, if I tell you to put a value on the relationship, okay,
One
percentage. Sorry? Well, you just thought about your own value, and that's why you're smiling. If I say put a value on your current relationship you are in terms of percentage, please, guys, mention your percentages for me quickly. Let me see. Don't worry about your name. Just mention the numbers and let me see something. Everybody. Percent. Nobody should mention 100%. Okay. I'm dealing with the positive ones first. Mention the percentage quickly. Say it in the air.
0.02.
Yeah, I mean, make it percentage. So that's 20%.
20%.
Who else? Quickly. Don't raise your hand. Just mention it. Anybody, mention yours. If you don't have a relationship, you just say zero.
Zero.
See, this tells me whether some are listening or some are not listening.
Zero.
1%.
All right, let's move on. So the strength of the relationship is determined by the value. Now, that is for correlation. That is for numeric data. But what we are doing here is not for numeric data type. We are looking at categorical data type. And therefore, the way you analyze that is separate. So the relationship between items, between one item and another item or multiple items, is determined by the joint occurrence of the items. And the joint occurrence of them will happen when they are all in that sort of a basket, okay, when they have created an item set. Now watch the word. The strength of the relationship between the item is built upon by computing a lot of probabilistic metrics, a lot of them. And practically, and see, guys, you're going to use some of it. It's not for IA, it's not for exams alone. You're going to use this in your long essays you'll be writing, but your colleagues. I think you've been allocated supervisors now, haven't you? Have you guys been allocated supervisors?
Yes, sir, we have.
Yeah.
Yes, Doc.
Yes, Doc.
Good. So now that you've been, yes, Angela, your hand is up. Now that you've been allocated supervisors, some of you will use association rule mining alone to do your work, market. And what we are doing will come handy at that time. So the relationship between item is determined by the joint occurrence of items in the item set. Now, items, what this means is that items that appear together frequently in the transaction, let's say in the shopping basket, in the logs, in the medical records, whichever one you are doing, clickstream data, and the items that appear together most of the time may have meaningful relationship. And these relationships are not assumed. They are discovered from the data. It is when you've collected, you look at the basket. But sometimes the one at the tilt who is collecting your data, the moment he sees some things, he can anticipate what's the next thing he's going to type in there. In fact, the machine will even anticipate what is the next thing. It's just like recommendation systems, okay, where Netflix will anticipate your next movie because you watched the previous movie. So if bread and butter appear together often in the basket, in the item set, then there is a relationship between bread and butter. Okay. Now the question is that there are 5 major metrics, most important measures for evaluating association rules that we are discussing. The first is the support. We are going to look at it, but please note all 5 of them down. The second is the confidence. The third is a lift. The fourth is a leverage. And the fifth is a conviction. Each one of them will be detailed if there's time. Otherwise, others, I'll let you go and read about them. Okay. Now, let me just put this on record that if you want to, for example, let's say that you want to fully understand any one of these, you don't only take the notes that you have. You want to just take this slide itself and just, dump it into Google and dig more, tell it to tell you more, a lot of things about this slide. And then you can expand your knowledge about it. So let's start with support. It is a measure of association rule. Okay, all of them are, measures of association rule. They are all trying to measure this association. We are kind of quantifying the association, and we start with the support. Support will measure how frequently X and Y occur together in the entire data set. Support. The number of occurrences of items and item sets. The number of times X and Y occur together. I'm giving you different ways for you to understand. So you got to be writing some of them. The number of times, not the number of times X occur, and not the number of times Y occur, is a number of times X and Y both occur together in the data set. It tells you the probability that a given item set appears in the data set. And how do you calculate it? How do you calculate the support of 2 items or multiple items? This is how you do it. You do that by counting Yes, follow.
Yeah, but Doc, here it says that it's the number of occurrences of items and item sets. So meaning the items are also included, or?
Yeah, the items are included. But the items are where?
Yeah, but yes,
The
that's the
items
X and
are,
Y.
yeah, but the items are inside the item sets, isn't it?
Yes.
Yeah. So if I talk about
But
X and Y, the X and Y are inside the item set, and the X and Y are the item set.
yes. And they're also the items.
Yeah. But it's the items that make the item sets. I'm just using two of them for
Yes.
now. That is why. If I was using multiple of them, that is different. But I'm using two of them for now. The probability that both item sets, okay, occur together in the transaction. That's a support. I'll give you an example and you will understand. Don't worry. How popular is the combination of X and Y in the whole data set? That's the whole thing. We'll look at an example. So, support is given by the frequency of the item set divided by the total items. Formally, if there are two items, X and Y, you see, I'm just using two items for now, then the support that if I see X, I will see Y, the support of X and Y is the probability that both item sets X and Y occur together in the transaction. And this is given by the frequency of X and Y happening divided by the total number of transactions. The total number of transactions. Okay, we'll take an example and then you get that. Let's take this example. And we'll be using this example a lot. So suppose we have the following 10 transactions. Look at the 10 transactions very carefully. And we are going to calculate the support here. We are going to calculate the support for some specific variables. We are going to calculate the support for milk. That is a probability that milk occurs out of the 10 transactions. How many times does milk occur out of the 10 transactions? So we are calculating P of milk. Who can tell me? You know probability to it. Out of the 10, how many times does milk occur? You see, I've done
Eight.
some coloring. I've done some coloring to just help you, but I shouldn't have done it. But yeah, George.
7 times.
Okay, so how would you write a probability of milk?
7 over 10.
Exactly. So that is 7 over 10. Okay. If you don't understand, you let me know. Now that is known as the support for milk. What we just did. This is the support for milk. Just know that S here is support. It's a support one. It's nice to write the full name. So the support for milk is going to be 7 over 10. What is going to be the support for bread? What is going to be support for bread?
4 over 10.
4 over 10. Do you all agree with that? What is going to be the support for milk and bread? George.
5 over 10.
Which one are you talking about? Did she say 4 over 10?
Yes.
Oh, no, it's not 4 over 10. The
No,
support for bread is
there's
5 over
another
10.
bread in number 8.
It's true.
That is not valid.
I deliberately didn't do that, but I didn't know that that is even going to affect. So, Tomasia, what you said, do you see the error there? Or it wasn't Tomasia, I was. So it's 5 over 10. Very good. So what is the support for milk and bread? The support for milk and bread. Yes, Richard.
Doc, 4 over 10.
How did you get that?
So 1, there's milk and bread. 3, there's milk and bread. 8, there's milk and bread. Then 10, there's milk and bread.
Okay. Guys, did you see what he said? So how many times does milk and bread appear together? 4 times. Transaction 1, and you see that there. Okay, transaction 1, okay, transaction 2, transaction 3, and then transaction 4. This is the one I deliberately didn't color. But see, when you color them, it makes it nicer for you to identify. So that is what we mean by the support for milk and bread. You know, we can ask the support for something else. Okay, what is the support for milk and bread and broccoli? Support for milk and bread and broccoli. I know somebody's eyes is combing on the thing. Milk and bread and broccoli. Sometimes your eye will comb through and then you get lost, lose track, but then come back, you can get it. Yes. What's the name? Let me take it to Richard. Welcome to the club.
1/10.
1/10. Do you all agree? I'm sure you all agree.
Yes.
Yes, please. Yes, please, we do.
So you see, support is not difficult after all. And we can find that we can take all of them in percentages. Okay. So this is it. These are the answers he just gave. Okay. Support for milk, support for bread, support for milk and bread, and all of that. And he can calculate the percentages in this regard. We can say, looking at all this, that it is more common to buy milk but not bread than to buy bread but not milk. Do you agree with that? It's a statement. I mean, just looking at this, it's more, let me just put it here, okay? It's more common to buy milk but not bread than to buy bread but not milk. Do you agree with that? And if you say yes, I want you to explain. Do you agree with that? Do you agree with that? Do you understand that? Yes, Angela.
No, Doc, I meant thumbs up, sorry.
Sorry?
I meant to use the thumbs up, not the raising of hands.
Okay. All right. So, yeah, but what I wanted was explanation. Why would you agree with it?
Okay, so since the probability of buying milk is higher than bread, definitely when you, not definitely, but it's more likely that when you buy milk, you buy bread. But since bread is lesser than milk, meaning you some bought bread without buying milk. Sorry, wait. I'm
Exactly.
coming. Okay, yeah.
Yeah. Some will buy milk without buying the bread because they'll just go and drink the milk. They just drink the milk or give the milk to the children, you know, so the child cannot chew the bread, so they just buy milk and then they don't do bread. But in some other cases, they will buy the milk and buy the bread because it's not only the child, it is for the older generations too who are also taking it. So that is the principle there. So support can tell you the strength of the relationship. So we're able to know the strength of the relationship between bread and milk. We're also able to know in this particular data set, we're able to know which one do people, will people buy more relative to the other when the two are going together. Let's go to the next one, confidence. Confidence. What is confidence? What does it mean? If you have a customer who buys X, how often do they also buy Y? That is confidence. That is confidence. If you have a customer who is buying a particular X, how often do they also buy Y? Now remember that this is different from support. Okay, let's go back to support. Okay. When you look at the formula for support, and in fact, even just look at the formula here, it is rather the X and the Y relative to the overall data set. But this one is just Y or X and Y, X, okay, or X and Y, but relative to X, not relative to the overall. So if we have two items such as X and Y, then the confidence will be giving us the probability of Y giving X, which means we are measuring the support for X and Y relative to the support for X. It's a very, very beautiful, measure of association rule. Given that customers are buying X, okay, how often do they also buy Y? And that is support of X, Y, all over support for X. So the probability of Y occurring conditional on X occurring. That is what we mean by confidence. So if you look here, we've indicated that the confidence formula expresses the probability that item set X, and X is a conditional, don't forget, leads to the item set Y, the consequence. So there is a consequence. And the consequence is not a denominator, it is a condition that is a denominator. Even though it is a condition that is a denominator, we have written the X as a condition. Okay, that's why we've written the probability of Y giving X. So X has already occurred before Y is occurring. That's the point. X has already occurred. That is why it is given before Y is occurring. So by the time Y occurred, X has occurred and Y is depending on X to occur. That is why we establish what? A consequence, a causality, than just a correlation. So let's go back to the supermarket example. The rule that buying milk leads to buying bread has a probability equal to the number of times bread and milk are bought together divided by the number of times milk is bought together. So we're going to go back here and then you calculate the support for me to see. I want to see whether you understand it enough. Sorry, to calculate the confidence. So what would be the confidence, okay, for milk and bread? Here I've killed the whole thing so that your eye will look at it. What would be the confidence for milk and bread? Who can calculate that? That means, first of all, you need to have something over something. The first, yes, Richard.
So no, please 0.4 over 0.7. That's 4 over 10 divided by 7 over 10.
Yeah,
which
you
is
should first of
0.4
all
over 0.
help them to understand where you are getting 0.4.
So the milk and bread is the 4 over 10, giving us 0.4.
And
Then
the milk and
the
what?
milk and bread.
They are what?
That's how many times they occur.
Yeah,
So
they are
in
what?
one,
They are
yes,
what is the 0.4?
their support.
Now you are talking.
Their support is 0.4. Then the
Good.
support of milk is the 7 over 10, which is 0.7. So 0.4 divided by 0.7.
And that gives you
0.5 something. I'm not too sure.
yes, 5 something. Somebody should help the guy. Judge. See if you are here and you are not participating, it's your hello.
0.5714.
Very good. What does that mean? Who can tell us? So that is almost 57%, right?
57.14%.
Yeah. What does that practically mean here? Let me see another hand. Valentina, welcome to the club.
Thank you, Doc. So what
I
it
always know the
basically
people who are now joining us, right?
yes, Doc, I've just been quiet watching. Doc, so it means that 57% of the time that people buy milk, they also buy bread.
Good. Say that again.
So it means that 57% of the time that people purchase milk, they also buy bread.
Yeah, I want you to say it in such a way that there is a causality.
Okay, so it means that 57% of times that people buy bread leads to the purchase of buying bread.
Who can say it another way? I mean, you're right, but who can say it in another way to make it even nicer? Yeah, Grace. Grace, welcome to the club.
Thank you. Please, 57% of people who buy bread will buy milk.
Sorry?
57% of people who buy bread will buy milk.
I like the way you are putting it, but I want to see whether the connection is. Say that again.
The 57% of people who buy bread buy milk.
That's wrong.
No.
Correct it.
Sorry.
That's why I said that
I'm coming.
people should explain it. Rama.
Yes, sir. So I'm thinking there's a 57% chance that people who buy milk also buy bread.
Yes, I like that word also. There's 57% of the chance that those who are buying milk will also buy bread. In other words, bread buyers. 57% of bread buyers also buy milk. Write it. It's not exactly how I've written it there, but I want you to write it. 57% of bread buyers also buy milk. That's the meaning. Who is not clear? All right. Now let's continue. Let's look at another example still on this. Let's look at we calculated bread and milk. We are calculating the confidence, okay? And when you calculate, yes, Benjamin.
So when you said 57.1% of those who buy bread also buy milk, because in the probability, it's only one person who bought bread and then buy milk.
Yeah, but but this is a probability.
So I was thinking it's 57% of those who buy milk buy bread.
Sorry, say that again.
I was thinking it should rather be 57% of those who buy milk buy bread.
57% of
57.1% of those who buy milk buy bread.
Yes, that's what we said.
You said 57% of those buy bread buy milk. That's what I was just.
Oh, no. Sorry, I said 57% of those who buy milk also buy bread. In other words, 57% of milk buyers also buy bread. I said bread buyers, right?
Yes, please.
Yeah. Well, there's so much bread I've taken and milk I've taken this morning. I think they are entering into my. Okay, 57% of milk buyers also buy bread, or 57% of milk buyers buy bread as well. Thank you for that. If I missed that. Okay, so let's go to confidence for the bread and milk. Now watch this. This is milk and bread. Don't forget, what we just did is milk and bread. Now we are calculating what? Bread and milk. What will be the value? You can tell us. We told you that it's not symmetric, if you can remember. What will be the value before we? Genia, hey, welcome to the club, Agbo.
Hello, sir. Please, I have a question.
Yeah.
Yes. So it's in relation to what the Benjamin said. The previous example we did, the milk, from my understanding, the
Previous
milk.
example is on the screen, isn't it?
Yes, please. So the milk is on the X. So the milk is our X and the bread is the Y.
Yeah.
Yes. And from your explanation, you mentioned that the bread is small. Let me see the constant.
The Y, okay, let me just, the Y is the one that is dependent on the X.
So Y depends on the X. So over
So
here,
this
the
is
bread depends
Y
on milk.
is milk.
Yeah.
Yeah.
Yeah. And the Y depends on X.
The Y is a bread, sorry. The Y is a bread, okay? And then the X is a milk.
Okay.
So you buy the milk, and that buying the milk will make you buy the bread.
Okay, that means that the X depends on the Y.
Yes, the X depends on the Y, exactly.
Okay.
The X depends on the Y. I have not indicated which one is the X and Y here for milk and bread here. But yes, X depends on the Y.
Okay. I was trying to do that like which one depends if
Which
X
one is your X and which
milk,
one is your Y?
Yes.
I've not
Based on
used that here.
Okay, I was trying to use that
But
based
when
on
you use
example.
that, if you want to use that, that's fine. But note that the Y depends on the X.
Okay.
The X occurs first.
So
and the
Y
Y
depends
occurs.
on X.
Sorry?
So please, Y depends on X.
Correct. Y depends on X.
Okay,
Let me just go back here, then you see that clearly. So here, okay, Y is conditional on X. But X occurs first. But of course, that's why Y depends on X, because X occurs first. X is a condition, Y is a consequence. X is the independent. Y is a dependent.
Okay. So, okay, sure.
Yeah.
So based on that, when I was looking at it, I was thinking then the milk, if it's the probability of milk dependent on bread, then that means that milk was going to be our Y and bread was going to be our X.
No, it can't be. Watch here. If you look at it, this is X, which comes first. Y comes second. In our case, X here becomes the milk.
Okay.
Which comes first?
Yes, please.
Y is the bread, which comes second.
Yes, please.
So in this case, milk affects the Y more or less.
Yes, please.
Or the purchase of milk affects the Y.
Okay, thank you.
All right. Now we are switching them. So I just don't want you to get confused. Now we are switching them. So you can see that here, bread has rather come first.
Yes, so now bread is our X and milk is our Y.
So since you all have the values for the support for bread, the support for milk, the support for bread and milk, you can calculate the confidence. So who can interpret this? This value of 80%, what does it mean? Angela.
Okay, Doc, so it means that there's a 0.8 or there's an 80% chance that people who buy bread also buy milk.
Yeah. That's what it means. So which one is your consequence here?
Betting that
Sorry?
Okay, so yes, I'm saying it brings us to our point earlier on that there are more people who buy bread who also buy milk than people who buy milk buying bread also.
Absolutely, you get it. You get it? For the earlier point we said, isn't it?
Yeah.
Yeah. I just hope the others understand. Okay. So that is the interpretation. It's the same thing. If bread is bought, the chances are, and there's an 80% chance that milk will also be bought. Okay. And there's a point you got to know that the confidence from milk to bread, the earlier one, is not the same as the confidence from bread to milk. We said that thing earlier. You said that thing earlier. So X mapping to Y is not the same as Y mapping to X. It's like when you are doing numerical regression, you can have something we call endogeneity, or you can have something called bidirectional relationship. For example, when you increase your price, the quantity demanded will fall. When quantity demanded falls, you increase your price. You know, that sort of thing. In other words, it is possible that, let's take, for example, corporate social responsibility and profit. It's possible that when you do more CSR, corporate social responsibility, you get more profit because your image and reputation will increase. So it appears that doing CSR gives more profit. But it's also possible that rather getting more profit is what makes you do CSR in the first place. So it's possible that one can be the condition and the other can be the consequence, or one can be the independent variable, the other becomes a dependent variable. But of course, these are categorical. That's why we are not using independent and dependent. So it's not the same. That's the point. Okay. And it's not a crisscross causality, basically. Now, so earlier, this is what we had. The support from milk was 0.7, support for bread was 0.5. We had this 2. So we can say that without any further information on buying bread, we could estimate the probability of buying milk at 70%. Okay. But if we know that bread is part of the shopping basket, then the probability of milk in the shopping basket is higher. It's slightly higher. That is what we just found at the top here, which is the 80%. So these are just for you to understand confidence and that of support. Any question on this before we proceed? Because I just want you to understand the early part. The early part. Because we are going to the next one, which is known as left. Left. Remember what left is one of the measures, one of the evaluation metrics. Left is one of the evaluation metrics. Okay, let's go to left. So this is left. Left is one of the metrics of association rule. It's one of the metrics of association rule. What is that? Left will compare the observed co-occurrence of X and Y. That's left. So watch it carefully. Let me just delete this. Yes, Benjamin.
We can see the formula very well because of the writing.
Yeah, I just cleaned it. Is it better now? Is it better? Because I've wiped it, unless you don't see.
Yes, please. It's better.
Okay. So watch it. In this case, the X is mapping to Y, which means that X is a condition and the Y is more or less the consequence if it is causation. If it is causation. So how do you calculate? In fact, what is the left here? We are looking at the co-occurrence of X and Y to what we would expect if they were independent. Sorry, yes, if they were independent. We are looking at how both X and Y occur. We are comparing how both X and Y occur with if they were separate, independent. And you want to take note of something here, because that is interesting here. Okay, let me just put all of this here. You want to take note of the fact that left, when the value is bigger than 1, and please write some of this in because it's not all of them that you're going to know. If the value is more than 1, then it means that X and Y are going to be positively associated with each other. if it's bigger than 1, I mean, it's similar to the other ones we've learned. But who can tell me if it is less than 1? If x, if the left value is less than 1, what does that mean? It means that x and y are negatively related to each other. Now, what if it's equal to 1? When it is equal to 1, when the left value is equal to 1, it means that x and y have no relationship. Just as in normal correlation, we will say no correlation. In other words, the two of them are independent of each other. That's what it means. Independent of each other. So the lift is calculated as support of x and y divided by the support of x multiplied by the support of y. It's just the same support that we are manipulating, which means that we are calculating the probability of x and y divided by the probability of x multiplied by the probability of y. But we know that the probability of xy, go back here, okay, the probability of bread and milk, or probability of milk and bread, is what is known as confidence. Okay, let me just take it back. Okay, so look at it. Confidence is the support for x and y over support for x. In other words, confidence is the probability of y given x. So we can say that, let's go back here. We can say that once you know the support, okay, of x and y, that is the confidence of x and y. And if you take this part here, okay, P of x, watch it. If you take this part here, watch it today. That little part I've bracketed. And let's go back to confidence. Watch that formula carefully. Okay. Let's go back to confidence. Okay. The confidence formula that you have here, watch it, is the support of xy, which is the probability of xy, divided by the support of x, which is the probability of x. So the support of xy, which is the P of, which is the P of xy over the probability of x, this one here is a confidence. Okay, so when we go down to the lift formula, come on. When you go down to the lift formula, you can see that that is what is here. Okay, and then the other part down here is just the P of y, which is the support of y. Guys, are you getting what I'm trying to do? So you need the previous ones we are calculating to be calculating the next ones. That's all it means. Angela.
Doug, please, what did you say the lift is all about again, please?
Very good. The lift tells you the co-occurrence. Okay, I indicated that people should write because I didn't really define it exactly there. Is the co-occurrence of x and y relative to what would expect if they were independent. Is a co-occurrence, okay? It is comparing the observed together happenings. That's what I use by co-occurrence. The observed together happening of x and y to what we would expect if they were independent. Because the co-occurrence here means that they are kind of dependent. They are occurring at the same time. They depend on each other. We are comparing their happening together with if they were not happening together. Now, in the formula, if they were not happening together, that is the down one here. You see, they happening, not happening together is the support x multiplied by support y. Is the probability x multiplied by probability y. But they happening together is the top part. Okay, so we are comparing the observed co-occurrence of this x and y at the top to they happening independently, which is the denominator. Does that explain?
Yes, please. Yes, please.
Okay, so now, based on this, can you any of you tell me the value for the lift? And remember that this is a correlation, not a causation. Not a causation, not causality. That is why you can see that the lift for X to Y is the same as the lift for Y to X. It's the same. The lift from X to Y is not like the other one, where we said that the confidence from X to Y is not the same as the confidence from Y to X. No, because they are causality. But here, the lift from X to Y, because it's correlation. The correlation between price and quantity demanded is the same as the correlation between quantity demanded and price. Okay. So what would be the value? Okay. I mean, if you guys were calculating from here, yes, Benjamin.
1.14.
Sorry?
1.14.
How did you get that? Sure.
And so support for XY is 0.4.
Mm-hmm.
And then the support for X is 0.7, support for Y is 0.5.
Mm-hmm.
So I multiply the 0.7 and 0.5,
Mm-hmm.
and then 0.4 divided by 0.35.
So the 0.4 is what? Is the adjoint?
Yes.
Good. Good. So guys, is a joint, okay? That's what we looked at before. The support for milk and bread was 0.4. And then this one was 0.5, right? Or 0.7. The milk. What was the milk? Support for milk was what? I don't want to go. 0.7.
Yes, please.
0.7.
And then support for bread is
0.5.
5.
So 0.5, 0.7 is 0.35. Okay, and then the numerator is already 0.4. So it becomes 0.4. So looking at this value of 1.14, okay, given that it is bigger than 1, what does that mean? What does that mean? Well, okay.
Okay, so Doc,
Positive.
so it means that the likelihood of buying milk and bread together is higher than buying milk individually or buying bread individually, meaning that they are highly correlated or associated.
Yeah, but how highly correlated or associated? My question is it positively or negatively? That's it.
It's positive.
Okay, what makes you say that it's positive? What makes you say
Because
that
it's
it's
more
positive?
than one.
Uh-huh. Because?
Because it's more than one.
Yeah, because it's more than 1. Okay. So what this means is that now we have a lift, which is 1.14. So it means that bread and milk occur together, 14% as often as their expected chance. That's what it basically means. Okay. 14 or 0.14 times as often as the expected chance would have occurred. That is basically, but I mean, what I said is probabilistic terms, but there's the same thing that Angela said in that regard. So your interpretations are very crucial, Tomasia.
Doc, with this one, please, when you're interpreting, do you look at the negative or you take the absolute?
You look at you look at the positivity. Okay, it's not negative, it's all positive. Okay, if it is less than 1, we say it's negative. If it is greater than 1, we say it's positive. It's positive all the time. But we are talking about whether that positivity is less than 1 or greater than 1.
Okay.
If it's less than 1, the relationship between X and Y are negative. If it is greater than 1, the relationship between X and Y, or bread and milk, are positively associated. In other words, they appear together more than expected. But if it is equal to 1, then we say that X and Y are independent. There is no association between them.
Okay, thank you, Doc.
Doc,
Okay.
please, I want to find out the
talking?
1.14.
Talking.
I know it's
Who
positively
is talking? I don't
associated.
see the person's hand. Who is talking?
Sorry, Edward.
Raise your hand so that yeah, go ahead.
Look, I want the exact interpretation for the 1.14. I know it's positively associated, but how do I interpret this, like in an exam or something?
Okay. I think one of you, is it Angela? Angela, could you explain it to me?
Okay, so what I said was that there's a 1.1 chance that people buying milk and bread is higher than you buying milk separately or buying bread separately, meaning that people buy milk and bread together more than buying them individually. So meaning they're highly associated. I mean they go together well. I don't know if you get what I'm saying.
Exactly.
Thank
I
you.
don't know
Thank
whether
you.
he understands it.
Yes, I
So
understand.
do you get it?
Yes, sir.
Yes.
Good. So it means that milk and bread, they occur together. We know they occur together, but they occur together, 14% as often as expected, to occur. I'm taking the 14% here, okay, not 14%, but 14% more, than expected by chance. Otherwise, you take 140% chance more. So it's better to buy them together than to buy them separately. And how better is it? It's better by more than, one. It's better by more than, they better, not twice as often, but by more than one. Yes, Joseph.
Yes, Doc. So please, I wanted to ask if there was a limit on the maximum value that the lift can
Infinity.
be. Infinity.
Yes, sir.
Okay. So then the limit is infinity. So it can be 14% more than
Yes. You mean the percentage value that I used?
Yeah.
Yes. It's 0.14 more.
Oh, okay.
That will help.
That
I was just
okay. All
trying to
right, Doc.
speak fast. Yes.
All right, Doc. All right. Thank you, Doc.
Yeah. Not twice more. Not once more. But 0.14 more. Or 1.4. 1.14. Okay, so that is lift. We've looked at support, we looked at confidence, we looked at lift. Now let's go to, yes, Benjamin.
So, can we say that when confidence per formula, the last
Let me go back.
slide. Okay, can we say that when confidence is greater than the support of Y, then we will likely have a positive correlation?
Always. You got it. Always. You're right.
Thank you.
You're going to have a positive relationship. Other than that, you have a negative relationship. There are so many connections that you can give or you can get when you're looking at this. Okay. So let's look at something related to this lift. It's a, before we go to what do you call it? Leverage. Was that the next one? I don't think we'll be able to complete leverage, but there are some things I just want to show when it comes to this lift. Let's go back here. So suppose there are 5 items. Item 1 is bread. Item 2 is jam. Item 5 is book. And suppose you have the following supports for each of those items. You have 0.7 for item 1. The support for 0.7 is item 1. The support for item 5 is 0.8, as you can see down here. Let me clean the top right so that doesn't block you. Good. Now, if we look at the confidence for bread and jam, and it goes back to the point that Benjamin was discussing some few minutes ago. If you look at the confidence for bread and jam, it should be more than the confidence for biscuits and book. Of course, I didn't mention biscuit, but biscuits is there. Okay, you can see biscuit is 4. Now, why do we say that? Because the confidence, let me just go back here. The confidence for bread and jam, I mean, if you calculate, you will know. Okay. The confidence for bread and jam should be more than the confidence for biscuit and book. But according to the previous information, we have the following scenarios. The confidence for biscuit and book is 75%. The confidence for bread and jam is 75% as well. So looking at the fact that both of them have got the same confidence, we can say that there is a 75% chance that a customer who buy a book, remember book goes with biscuit. Okay, there's a 75% chance a customer who buys a book, if he already bought a biscuit, that's what we can say. That as long as the person has bought a biscuit, the person will have that. And then we can also say the same thing between bread and jam. I mean, this is something that we've done already from confidence. Okay. Logically, the confidence for bread and jam should be greater than the confidence for biscuit and book, logically. Now, look at it from this perspective, guys. Book and biscuit, technically, they don't have anything technically in common. Bread and jam seems to have something in common. And I'm talking in real life.
Yes, Doc.
But here, it didn't happen. Okay? It didn't happen in this particular example. Okay. However, according to the lift formula, if you can remember the lift formula, we have the following. The lift for item 1 and 2, and when we say item 1 and 2, okay, just so you don't ask me which one, is bread and jam. And then, back on what? The lift for item 1 and 2, which is confidence, the lift for item 1 and 2 is bread and jam, is actually going to be the confidence between the two divided by the support of the second one. Okay. And it will be good to actually use the names, but at least you understand item 1 and 2. And again, if you don't understand any particular, remember item 1 and 2, we are talking about bread and jam, bread and jam, bread and jam, bread and jam. Okay. So if we calculate their lift, it means that the probability of the presence of item 2, and item 2 is actually the jam. The probability of the presence of item 2 or jam with the knowledge that bread is already present in the basket over the probability of the presence of jam with the knowledge that bread is in the basket. Okay, so if you look at this lift formula helps you to be able to interpret the confidence for both item 1 and item 2 relative to the support for item 2. We can calculate the lift for biscuit and book. This will give you 94%. If you check above, they are all above, you see it. You can calculate the lift for bread, okay, which will give you 1.01%. So you can see that one is positive, the other is negative. What does the above ratio tell you? For me, it tells me something. What does above ratio tell you? There's something about lift that is interesting. That's why I'm concluding with that. What time do we close? Is it 9? Is it 10? For Falake? Your hand is up.
Okay, I was about to answer the ratio
Okay,
suggestion.
go ahead. Go ahead.
Okay, so from what I'm getting from this is that, meaning that the bread and jam are highly sought out or bought together than biscuit and book, meaning that though biscuit and book have some form of correlation, people buy biscuit and book independently than buying them together compared to bread and jam.
It's perfect. But then the previous one actually gave us what impression? Looking at the confidence. I mean, you're right. Yeah. The fact that they both have the confidence of 75.
Yeah,
Right.
meaning that they still have some form of correlation.
Yeah.
But then when you should check their lifts, it shows that they are rather bought more independently than together, though they are also bought together.
Yeah. They are correlated. They are correlated. Okay.
Yeah.
But I saw George, your answer, your hand.
No, sir, it's okay. She has answered.
Or you're going to tell me the time. What time do we normally close?
It's 10. Yeah.
Okay. I have another lecture at 9:45. Let's move on. So, where is it? So, what this means is that when you have that of the first one, the confidence, because the confidence are the same, okay? Now, if you guys could remember, what does confidence measure? What does confidence measure? What does confidence measure? Confidence will tell you that if you have bread and you buy bread, you will also. It establishes causality. Do you remember that the only place where there was a causality was confidence? That was it. So the confidence was where we were using a conditional probability that you only buy X if you have bought Y. But then it gave us the idea that the jam, let me just go back here. The jam and that of the bread and the biscuit and that of the book have got the same confidence. And if they've got the same confidence, which means that from biscuit to book and from bread to jam, there is a causal relation. In other words, you are buying jam if you bought bread, and you are buying book if you bought biscuit. Okay. In other words, the two of them have got the same chance of causality, but the two do not have the same necessary chance of correlation. And that there is a high correlation between bread and jam than there is between book and biscuit. And again, this goes to prove that the correlation does not necessarily connote causation. Write it down. Correlation does not connote causation. And I'll give you a typical example for you to understand. Let's say that during Christmas coming, a lot of people on the day of Christmas, December 24th, or December 25th, you went to the restaurant and you told your friend to also go to Agbogboloshi or Makola. When your friend went to Agbogboloshi, so many people are making sales to go and buy items to go and cook food. And so normally when it is Christmas time, we notice that people like to cook at home, isn't it? Guys, confirm it before I continue. People like to do family chops, isn't it?
Yes, sir.
Yes.
Which means that what will happen at the hotels and restaurants? What will happen?
Meaning so
That would be empty.
Hey, you are using empty. Okay. The presumption is that hotels will not get a lot of customers. But then you check the hotels and you visited a couple of hotels and restaurants, they were fully packed as well. So you see, you are likely to say that Christmas will lead to more purchases at Agbogboloshi market. The Christmas period will lead to a lot of people buying or increased demand for food start or food at Agbogboloshi. But you also saw that demand for food at the restaurant has also gone up. So we can say that the two of them are what? The two situations are what? Like demand for items at Agbogboloshi and demand for items at the supermarket, at the restaurant. The two of them, that demand for both cases are what? They are highly correlated. Is that what you're going to say, George?
Yes, sir.
They are highly correlated. But then not what? But then not what? Not, you see, they are highly correlated. Maybe the correlation is even 0.898. But then what? They are not causing each other. So they are correlated, but they are not there's no causality. In other words, somebody might think that because there is an increase in the demand, I mean, I gave you guys the premises already, so you know, because there's an increase in demand for foodstuffs at Obobolochi, and there is an increase in demand for items being bought at the hotels, because both of them have got a very high demand, one might think that it is one of them that is causing the other. But that is not the case at all. Actually, it was the season. And in fact, one of you even thought that it's going to cause the hotels to dwindle. It's not true. You just check. The hotels will still increase demand, isn't it? Because people have preferences and they'll all go. So there will still be demand, but there's no causality, but they are both being caused by an external factor, which is the Christmas season. So in short, there is correlation and there is causation or causality. Correlation does not imply causality. That's all I want to say. Okay. So whereas the lift is establishing correlation, the confidence is establishing causality. That is why you see that the lift for biscuit and book now is 94 and that of this. So the above ratio tells you all of the things I've discussed. One, the probability of buying a book with the knowledge that biscuit is already present in the basket is lower than the probability of buying a book with the knowledge about the presence of biscuit. That is interestingly critical. Okay, so that's the first one. The probability. Second one, the probability of buying a jam, knowing that bread is already in the basket, is much higher, and that is a jam. Okay, as you can see, it's much higher than the probability of buying a jam without knowing about the presence of the bread, because that is independence that we spoke about, without knowing. The presence of the biscuit, the third one is that the presence of the biscuit in the basket actually does not increase the probability of buying a book. No. So there is no connection there. That is why you see that 94%, that's why you see that 0.94 value. The presence of buying the biscuits in the basket doesn't increase the probability of buying the book. Yeah, they have some connection. That's why it's a negative correlation there. The presence of the bread in the basket increases the probability of buying a jam. Yes, because they are highly correlated, positively correlated. And also the number of customers buying both biscuits and books might be less than the number of customers who buy the only biscuits. And I use the word might less because it was closer to 1, but also negative. It's still showing a negative relationship. And then that same thing will go for the jam. The jam case will be more than, whereas this one, the biscuits and books will be less than. So if you take the lift between bread and jam, it's more than the lift between biscuit and book. And it matches our common sense that bread and jam are more closely associated than bread and book. So this interpretation must help you in that example that I gave you, okay, that there is no correlation does not mean causation. Causation does not mean correlation. Causation implies correlation, but doesn't, you need to establish causality before you need to establish correlation before you can establish causality. But once you establish correlation, it doesn't mean you've established causality. You need causality. You need correlation to do causation, but you don't need causation to do correlation. Now let's go to the last one, or the last but one, leverage. Leverage. Just think about the word leverage. Leverage. Okay. You remember the lever, the pivot, the effort, the lever, the pivot, the effort, the lever, the pivot, the effort, the lever. Leverage tells you how much more X and Y occur together than expected under independence. That's it. You ask me later to tell you the definition. I've just given you. Okay. So you want to write it down. Leverage measures how much more X and Y occur together than expected under independence. It's actually measuring the actual difference, not a ratio. Okay, not a ratio, but actual difference, as you can see up there. So you are looking at the difference between the support of X and Y, and then minus the support alone for X and the support alone for Y. It's just like the one before, but that one was a ratio. Okay, if you go back here, okay, and you look at the definition for lift, okay, it is a support of the joints divided by the support of them separately. But this one is the support of the joint minus the support of them separately. The separately is their multiplications too. So that is it. The support of X and Y jointly minus the support of X and support of Y separately. That's leverage. In other words, the probability of X and Y minus the probability of X multiplied by the probability of Y. That is why I said, yes, Angela.
So, Doc, if I'm getting you, you're saying the main difference between the lift and the leverage is the fact that the lift is in a ratio.
That's it. That's it. That's all. The lift is in a ratio, the leverage is in a difference.
Okay, so then at what point do you use the
When
lift
you are
and the
using them,
leverage?
you use all of them to give you the strength of the relationship. Okay. So when you are trying to evaluate the relationship between, say, two different items, like we've been doing all along, you got to use all of these matrices or metrics to guide all of these measures so that you will see that, okay, they are all leading to the same conclusion. They are all telling you that, you know, the relationship between this and this is going that way. So you use all of them. You don't use one of them. And in your supervised learning that you will do next semester, you see that that one is easier. Okay, this one is a little bit complex. In the supervised learning, you see that again, you will use all of the evaluation metrics. So your question is, which one do you use, right? Or you are okay with it?
No, my question was, at which point do you use the leverage and at which point the lift?
But now you know the answer to that question.
Yes, please.
There's no at which point. You are using all of them to analyze your work. Okay. Let's say that you use one. One comes to say that this is the case. The other comes to say that this is not the case. One comes to say that this is the case. So once you have all five of them, and all five of them say that, out of the five, four of them say that this is the case, but one is saying that this is not the case. Which one will you take?
The 4.
Exactly. But what if you had only one? You may have made a mistake. Does that answer your question?
Yes, please.
Yeah. Okay. So that is leverage. Okay. So suppose you have a leverage of 0.02, for example. It means that X and Y, they occur together 2% more often than expected. That's what it means. And please note that leverage is also between -1 and +1, inclusive. It's just like the lift. Remember the lift? Okay. The lift is not like that. Remember the first one, I think it's support. Which one was between -1? Was it support? But anyway, leverage is between -1. It's a clear example of a correlation. It's a clear example of a correlation measure. And then, of course, I want to just touch on this one before I mention the two. Okay. I want to touch on both these two, leverage, and then the last one is convection. Convection Convection is 1 minus the support divided by 1 minus the confidence. That's conviction. I mean, look at the word. You are convinced. You are convinced based on support and confidence. Okay. You are convinced. Did I even talk about that? Okay. When we're starting, when we're listing the items, did I add when we're looking at association rule mining? Yes, conviction was the last one. So conviction, okay, you need support and you need confidence to be able to establish conviction. Support and confidence. Support and confidence. Let's try to put them into our work. So we had leverage for milk and bread. We already know. For you to be able to calculate leverage on milk and bread, you need to know the support. You remember the support was what? 0.4? And then this one was 0.7 and 0.5, giving you 0.35. I don't know. But you guys have the figures. Okay. So you check the figures and you see that they will give you exactly, they'll give you 0.05. What does this 0.05 mean? Okay. What does this 0.05 mean? That's the leverage. It means that the bread and the milk co-occur 5% more often than expected. Write it down. Write it down. They co-occur 5% more than expected. That is what it means. And then you can, of course, calculate the last one, which is what? Conviction. My computer is frozen. Okay. You can calculate conviction here. I mean, you can substitute and then you see. I just don't want to do the calculation, but you know this calculation. But what is conviction here? Conviction measures how much the ruling will improve prediction. How much the rule will improve prediction of not the Y and not Y and how do I put it? Okay, conviction tells you how much the rule improves prediction of not Y when X occurs. It's a very, strange way of looking at it. Will the rule improve prediction of not Y when X occurs compared to assuming independence? Okay, that defines your conviction level. So conviction is greater than 1 or equal to 1. If you have higher value, conviction is always greater or equal to 1. Okay, if you have higher values of conviction, what does that mean? If the values of conviction are big, more, it means that X and Y are independent. X and Y have a stronger association. But if it is equal to 1, it means that X and Y are independent. Okay, so if you look at our case here, we had a value of conviction of 1.16. Okay, so what does that mean? It means that the bread and that of the milk, the first one is what? Bread. The first one is milk. So milk leads to bread. Okay, 1.16 times better than if milk and bread were independent. That's what it means. That's what it means. If you want an interpretation, that is what it means. I can repeat that. It means that milk leads to bread 1.16 times better than if milk and bread were independent. That's it. See, my other class has started now. People are joining this other class. So guys, these are the matrices that you can use to analyze that of association rule. So in short, association rule mining is trying to establish the pattern, the association, the relationship, among items, okay, in a basket of items. That is what it's doing. Okay, so let's summarize it. Support is a parameter that tells you how frequent an item shows in the basket. Okay, high support means that the items co-occur frequently. Confidence tells you how often a rule is true within the data set. High confidence will tell you that the rule is often true. Lift can be computed by finding the percentage of transactions containing the item. High lift will tell you dependence. I will tell you dependence, and that the rule is not just coincidence. And you can see all of them, kind of structured beautifully together here. Now, there's one more thing before we wrap up here. No, that's it. That's it for now. Okay. So next time we are going to continue by looking at what we call the integration of these lifts, the integration of this lift, and then we can wrap up. I will also look at the application of this in Python. We shall apply this thing in Python using its data set, and everything will beautifully fall into place, and you can see the association with graphical interpretations. Ladies and gentlemen, that brings us to the end of the entire caboodle. Any question, please? Any question?